Hello all, welcome to this session about product CAENexus. CAENexus is a automated preprocessor which helps to automate CAE workflows. CAENexus supports CFD solvers such as Accusol, Fluent, CCM Plus and OpenFOAM. It supports FEA solvers such as Abacus, OptiStruct, Nastran, and ANSYS. Let us review how CAENexus works with this simple viaduct assembly model created in Creo software. This is a Creo assembly which has different parts. This is duct skeleton. Then these are the different legs. This is one important role in CAENexus automation. In this role, CAD engineer will create simulation geometry. Simulation geometry is created in any CAD software of user's choice. The next step is to give parameters such as SCOM and S-class. These parameters SCOM and S-class are recognized by CAENexus. SCOM stands for simulation component and S-class stands for simulation classes. Let us see how to give these parameters values in Creo. Go to Tools, Parameters, select part such as the duct skeleton, add the parameter as SCOM, choose the type as string and give the name as connecting pipe. Add another parameter called S class and use it as a string, and you can give it as air. So similarly, user can add these parameters and its values in each part. Each CAD software has its own way to give these parameters and tags and values. Instead of giving all the parameters and its values, let me open already created or already tagged CAD model. Here you can see SCOM names are given to all the parts such as like connector pipe, inlet pipe, outlet pipe, and so these values are unique. Yes, comp values, and these values of SCOM represents component names. So rest all are S class values like air, fluid, size A, BL wire A, etc. So these values represents physics of the problem. So SCOM values are unique, but S class values are common across the different parts, which represents the physics. Let us see how CAENexus use these values of SCOM and S class to set up a simulation in abstract model. So this is CAENexus abstract model window. This is class widget, then class relation widget. Then it has four tabs: meshing, solution strategy, problem definition, and output. So let me create some class called as air, and on this class let us create a cell zone attribute of fluent. So attribute is created on air, and we have selected its material as air from fluent database. So anyone familiar with fluent will not feel that it is different. In traditional process, we apply all these attributes on geometry or mesh, but here we are applying it on simple string, which is we call it as classes in abstract model context. So this is the role of CAE analyst, that is to create the abstract model which will store all its CFD knowledge. Let us see the three steps processes performed by machine. So instead of authoring all the AMF, I will open already created abstract model file. So here you can see mesh attribute tab, all the meshing attributes are defined on size A. The mesh size is defined. In solution strategy, you can see all the solver physics is defined. In problem definition, all the boundary conditions are defined, cell zone conditions are defined, and output tab is for monitoring purpose. So this is the AMF file created by analyst. Next step is to create simulation model. To create a simulation model, it will ask the CAD model, and here we are selecting the already tagged CAD model. So now this abstract model will combine with CAD model, and this will create a simulation model. Now if you click on, let us say, class air, it highlights this connector pipe. Let us go back to CAD, and we can see the air class is attached on connector pipe, while air porous A is attached on all remaining parts. So in simulation model, we can see air class is attached on connector pipe and air porous A is attached on the different legs. Let us review the attribute we created, like this. On air class, this air zone is created. It is highlighted in the window. From class, it will go to corresponding components. We can see that air zone is passed on connector pipe. And let us see how it goes on model. The same attribute will be seen in the model tab. Here if we select air zone, it will still highlight this volume 1, and it will highlight the connector pipe. So this is how each attribute is transferred from class to its real geometry when we create a simulation model. The next automatic step is to create the mesh, and all the mesh attributes which are defined to create the mesh, like mesh size. So next step is to create the mesh model. Next, the last step is to export fluent input data. So I am creating export folder, and I am selecting this folder. It will start exporting. While exporting, it will take all the data which is transferred in model tab. So let me show you this export file of Fluent after completion of export. So export is completed. So let me show you the exported files from the export folder. So here we can see that in input folder the surface mesh is exported, and there are some scheme and journal files are exported which are required for automatic meshing and case setup for Fluent Solver. So this is how export is done in three simple steps, that is create simulation model, create mesh model, and export solver deck. Let us talk about advantages of this abstract model processes. So here user or analyst is specifying the attributes on classes which are simple strings. These classes represents physics of the problem like a cell zone condition, boundary condition, or mesh sizing, etc. And across any two components of CFD, this physics will remain more or less same. Hence, this abstract model file will be reusable across the organization for different problems. Second advantage is that all the knowledge of CAE analyst has been stored in this very simple abstract model file. This knowledge capture will definitely help when other less experienced analyst or designer will try to run the simulation. The third advantage is that with this process, simulation can be run 24 by 7. So let us talk how this could be done in three simple steps. Let us see how CAENexus scripts can run multiple models very easily. Here we have selected two models, like very simple models for demo purposes, Yduct model and Ytube model. And here I have created a simple dat file which specifies the name of the model, AMF location, and geometry location. This is the second model. To run this, let me start the command prompt. So this is the command CAENexus command prompt. Let me go to this directory, and here I have to run the simple bat file. So it will start processing both the models one by one. So behind this script, a very simple APIs exposed by CAENexus. For example, load abstract model, which loads AMF file, then load the CAD model, which loads the CAD model, then create simulation model. Yeah, next is create mesh model. So here through this API it will create the mesh model, and the last step is create the export. So these simple scripts start working in non-UI mode, and this could be used to really automate all the workflows where everything runs in background. With simulation process management software, this workflow is very powerful tool for the designers. So this is all about how CAENexus works. Thanks for the watching and have a nice day.